Okay, good morning everyone. Welcome to lecture 11 of cloud computing. So, in this lecture, we will continue our discussion on design of cloud computing platform. Last class, we discussed about three specific platforms. One is from Amazon, another is from Microsoft, okay, another is from Microsoft Azure, and another from Google, that is Google App Engine, right? We continue our discussion on that. After that, we will discuss how data center is designed and how the resources of the data center are interconnected each other. So before going to these such platforms, you know that these cloud service providers are providing various services, that is IaaS, PaaS, and SaaS. They also provided public cloud, private cloud, as well as hybrid or community cloud, right? Hybrid and community cloud. So first, if you go for infrastructure as a service, in infrastructure as a service, the services provided subscription based services, and they are following pay as you go model, right? Or pay as for your usage model. Based upon your usage, you are going to pay for it, right? And before providing any kind of service, what they are doing, they are signing in the form of a agreement that is called as our service level agreement. Both cloud provider as well as the cloud consumer need to sign any particular document, right? So there is a issue here, like although service level agreement is a contract or an agreement between both user and provider, which deals with your service availability. Okay. For example, the service will be available 23 into 7. Instead of 24 hours, it will be available 23 into 7. Just like IRCTC website, that we need to mention in SLA. The performance, or you can say reliability of the system, need to be mentioned. Details about the privacy and security issues also need to be mentioned in the service level agreement. So there is an issue with the service level agreement, that this service level agreement varies with respect to the cloud service provider. Like you know that for a student case, you have also on various degree from many universities, right? 10th, 12th, and let's say BTech, right? You will see, if you see the mark sheet formats or degree formats, right, of each and every university is different, right? They are different from each other, right? One may use write the roll number in the left corner, another may use in the right corner, another may write in the bottom left corner or bottom right corner, right? Similarly, the service level agreement with respect to the cloud service provider, right, is different, right? Either n cloud service provider is there, so in the worst case there are n service level agreement is there. In many cases, it is observed that whatever service level agreement is prepared by a cloud service provider, right, that is simply signed by a user. It is true also in our case, whenever we are installing a particular software, without reading the terms and conditions, we are simply writing, I have understood the terms and conditions. Because even if I go and try to understand what are the terms and conditions for that particular software, I may not feel comfortable to understand the technological term, right? That's why what happened? Standardizing a service level agreement is required. For example, let's say as a user, you have properly understood the service level agreement of cloud service provider one. Okay, you have gone through the details of the document and you thoroughly seen the document and you understood what is there in that particular document. Tomorrow, if you want to switch your cloud service provider from one to two or any other cloud service provider, then you have to again read the terms and condition of another cloud service provider. That is in a different format. Different terminologies are used. So more or less you will understand, but complete understanding the document is very difficult, right? That's why many organizations are coming with a solution that is called a standardization of the service level agreement. If you standardize the service level agreement, for example, you know that there is an agency called as the National Academy Depository, okay, that is NAD. Okay, it is a repository. NIT is a repository which is now providing certificate on behalf of various organizations. Okay, like NITs, IITs, state universities, right? All the certificates now undertaken will the process has already started, right? And now everything needs to be stored in a NIT. Like you are storing your driving license in some Dropbox kind of thing. Okay, you are installing an app. In that, you are writing your driving license number. Then, accordingly, the driving license card is present in the smartphone, in your app, right? Government initiated an app, right? Similarly, all the certificates will be stored in the NID, right? And through a interface, it will be provided to each and every student. So whenever you are going for one organization to another organization or any interview, you need not worry about your document. Everything will be there in the cloud. So this is possible if there is a centralized agency who is generating the certificate. Similarly, in this case, if standardization of service level agreement will happen, then if you understood a single document, you can claim that I have understood all the documents because they are also in the same format. The values may be changed. Somebody is providing 99%, another person may provide 95%, but the format is same. Like if you decided that roll number is present in the left top corner, then in all university it will be present in the left top corner only, right? So this is a good solution. If there is a standardization will happen, then user may feel comfortable to understand the document, right? And user can easily switch from one cloud service provider to another cloud service provider. So while signing the service level agreement, user is aware of it. Otherwise, in the most of the cases, like we are installing the software, there is some terms and conditions. We have simply click the terms and conditions, right? You don't want to go through the internal details to understand the thing, right? So these are the three models that we discussed. If you are already aware of these things, just I will go in more details with respect to the cloud computing platform, right? Software as a service is nothing but the applications, right? Application end using spatial interfaces by users and clients. So you may have a portal, you may have a portlet also, or you may have a web browser. By using that, you can access to the cloud. That is the responsibility of service, software as a service, right? So you require a special interface or you require an user interface in which you can browse the website of a particular cloud service provider and you can invoke a particular service, right? Coming to the next layer, that is called as a platform as a service. Platform as a service is providing a runtime environment in which you are executing your application, just like an operating system. Apart from that, it is also responsible for billing services. Based upon your subscription, okay, or based on your pay-as-you-go model, okay, what it will do, it will generate the billing services. Okay. Or if multiple applications are launched by a particular user or multiple application launched by multiple users, they need to be placed in a queue in order to assign the resources. That is we call it a job queuing. Job queuing means there are multiple jobs are there. Okay, I have to place these jobs into a particular queue, right? Okay, so that the job which is present in the front of the queue, I am going to assign the resources to that particular job. Then to the second job, then to the third job, then to the fourth job, like that it will go on. So that is the responsibility of your platform service. And launching the services, monitoring the services, okay, monitoring their status, any kind of failure, like I told you previously, also fault tolerance is also responsibility of our platform as a service. And infrastructure as a service is based upon the hardware, where databases is there, compute instances are there, file system is there, and storage is there. Basically, these things are available in a server, okay, in which we are creating the virtual machines. So this picture will give you the complete idea. So this picture shows the IS, PAS as well as the SAS. cloud service model at a different service level. Here, user is present here, right? Any number of users can present here subjected to the availability of the resources of a particular cloud service provider. And it is assumed that the cloud service provider is having infinite number of resources. They have their restrictions, but the resources what they have, the resources what we require, if you compare that, there is a huge gap. That's why we are assuming that the cloud service provider is having infinite number of resources, or you can say unlimited number of resources. But practically, they have a limited number of resources. But whatever things they are claiming is unlimited. Okay, unlimited resources, right? They are claiming unlimited resources because we cannot reach that particular limit. That's why it is called like unlimited resources. So the first part is your user, right? User is using your cloud system through a client interface. The interface may be your web browser, whatever you are using, maybe Internet Explorer, maybe Google Chrome, maybe your Mozilla Firefox, whatever browser you know, maybe, okay, or there may be portal also. Like you are accessing some student portal, you have a link, by using that you are accessing the resources, right? So this is the responsibility of the software as a service layer. Then coming to the platform as a service, platform as a service is responsible for monitoring the queue, launching the queue, and billing management is also responsibility of the platform as a service. So everything is controlled here, right? It is everything is controlled, and finally once the service is rendered, the billing service or billing catalog is directly shown to the user, so that user will be aware of that what kind of services the user is using, and if he is using a particular services, how much he is going to pay for that service. Or once the services is completed or services is solved, then the billing unit is going to provide the bill to the user, or will deduct that from the credit card of the user, right? But if you go for infrastructure as a service layer, you have database, you have infrastructure, and you have distributed file system. So if you remember, I told you in some class that I told you about Hadoop, right? So what happened there? There is a master node in the cluster also. There is a cluster head or there is a master node who assign the work to some other nodes that we call it a worker node. Okay, the master node is going to assign the work to worker node. Generally, master node decompose the application into small pieces. Each and every piece is assigned to the worker, right? And worker is going to execute that. Worker is going to execute the small unit of work. Once the work is completed, the worker will again send the return the work result to the master node. So it is the responsibility of the master node to again to gather all the results, finally return to the user. So this is the various service levels, okay, using your IaaS, PaaS and SaaS, and their responsibility is also for you this particular figure. Okay, so these services or any kind of services, whatever we are asking in cloud, they are providing based upon the rental service, you can say. Just like in the real life, we are using Ola and Uber cab. The cab is not, we are not owning that cab, right? The cab is belongs to some party. The driver maybe belongs to some other organization. Just we are using that cab for a particular period of time. Okay, or we are using the cab for moving from one position to another position. So here also what we are doing, we are going for rented service. Similarly, in cloud also what we are doing, whatever resources a cloud service provider has, that resources we are assessing in a rental basis. Once our job is done, we return. And how we are assessing this one? Through internet. Okay, they are that is present in the provider end only. So through internet connections, remotely I am assessing the resources. Right? What we can do? We can deploy the application, we can run the application over the operating system environment. That's why I told you that there is a host operating system and there is a guest operating system. Right? In order to install the guest operating system, host operating system is optional. Right? On top of a host operating system, you can install a guest operating system. Just I am installing Linux on top of Windows using VMware, which is a hypervisor. Right? So it may happen that the guest operating system I can install without the host operating system as well. So that is the flexibility given in the virtualization technology, right? So you should know what is the responsibility of a user and what is the responsibility of provider, right? For example, in this case, user does not manage or control the underlying cloud infrastructure. Cloud infrastructure is a part of our cloud service provider. So managing this infrastructure and controlling this infrastructure, which VM need to be deployed in which physical machine, that is the responsibility of the cloud service provider, not by the user. But what user can do? User can control the operating system, storage, deployed application. So by looking into the APIs, you can configure your application, and networking components is the responsibility of the user. So many organizations are moving to the cloud without understanding the underlying technology. So after using the technology, they are saying, so we are not familiar with these things. We do not know how to deploy an application and how to control the operating system of storage. Right. That's why these things need to be well defined in the service level agreement. Right. Or it need to be informed to the cloud consumer so that they will not face any difficulty. They should know what should be delivered by a cloud computing provider and what should be done in his own end. Right, that we have to be very clear. Right, otherwise it is difficult to manage all the parts by a cloud service provider. So as you can see in the previous slide, the infrastructure as a service is divided as a storage as a service, or it can be provided as a computing instances. Especially in Amazon, we are called it a EC2 instances, electric compute cloud instances as a service. And also, few people also use the communication as a service, right? These are the services coming under our infrastructure as a service. And the infrastructure as a service provider is your GoGrid, FlexiScale, and Anek is providing your infrastructure as a service. Many providers are there. They are providing infrastructure as a service as well as the platform as a service, as well as the software as a service. So you may find, right, like Anek Cloud may be in the platform as a service, but it is listed here as the infrastructure as a service, right? Somebody may provide IaaS pass at the same time as well, right? So they may listed as the IaaS services as well as the platform or software as a service. So these are the examples what I want to discuss, right? Like I told you about various cloud service provider. So if you see IaaS, there are 5 popular infrastructure as a service providers listed here. One is called as your Amazon EC2, right? Another is GoGrid, another is Rackspace Cloud, FlexiScale, generally it is used in the United Kingdom, right? And Joint Cloud, right? Their different features are written here, right? And what are the APIs used by this cloud service provider and hypervisor is listed here. See, I will go for Amazon EC2 especially. In Amazon EC2, a user can access the resources of Amazon through a instance, which we call as a EC2 instance. If you want to use the services, we call it an EC2 instance. And these instances vary in size. I told you already in some class that we are using 3 instances, that is T2.micro instances. Right? Okay. There is also some instance that is large instance. Right? There is some instance that is called as a text large instance. Right? Lot of instances are. Okay. Based upon your each and every instances, why they are different? Because the number of processors, number of memory, okay, the size of memory or the storage size is different. Okay, that's why it is listed here. Each instance has 1 to 20 EC2 processor. It may happen that small number of processor is provided in the micro instance and more number of processor is provided in the X large instance. Similarly, memory case. Okay, memory case it can provide 1.7 to 15 GB of memory. So these are the some limits they have provided with respect to the instances. If you need customizations, you will need to contact a particular cloud service provider personally, right? And if you see the storage, it is providing 162 1.69 terabyte of storage, right? And the hypervisor used by Amazon EC2, they are using Gen and Linux and Windows. These are the hypervisor and operating systems are used in Amazon EC2. Like that, you can compare what kind of instances is provided in the Go Grid. You can see Go Grid is providing less number of CPUs, that is 126 CPU. In comparison to the memory of Amazon EC2, you can see the memory is 0.5 to 8 GB. Okay, storage is 30 to 480 GB. Okay, so the instances provided by each and every cloud service provider is also different, and they vary with respect to their instances. And the applications API also used by various cloud service providers is also different. Like here we are using SOA architecture, that is called command line interface or web service portal. But others may use PHP or Java, okay, as a API and SS tools, right? Their hypervisor is also different, based operating system is also different. Okay? But in the infrastructure case, many people relying on the maximum revenue generated by Amazon EC2 only. Many people trusted in Amazon EC2 in comparison to other cloud in order to get the services. Others, you please go through it, and I hope there is a free tier for each and every cloud service provider, right? If you want to access the cloud service provider, you can create an account and you can use the free services for a limited period of time. See this one here, there is a specific Amazon virtual private cloud is there. So let us assume that client is present here. So this is your customer network and this is your Amazon EC2 network. So Amazon EC2 network and customer network is connected to a virtual private network. Okay? That is called as your secure virtual private network connection over the internet. Okay, your network is connected to Amazon cloud service providers network through a VPN. Okay, virtual private network. You have a virtual private network gateway also. Okay, virtual private network gateway connected to a router. Okay, then at the end you have the resources, and these resources are provided in the form of EC2. That's why it is connect EC2 here, right? So your EC2 instances may be predefined, right? Like you want to launch a particular virtual machine. VM template is already defined. You have to choose the VM template and use the EC2 instances. If you need customization also, that is also provided by many cloud service providers. But all the cloud service provider is not providing the customization. Customization means one instance is providing 2 GB, another instance is providing 4 GB. But your requirement is 3 GB, right? One requirement is 2 GB, okay, that is there. One is 4 GB is there, but your requirement is 3 GB, which is in between 2 GB and 4 GB. And you are reluctant to use 4 GB instances because it is too costly. So what you will do in this case? You will go for the customizations. You will ask the cloud service provider to provide 3 GB only, right? If 2 GB and 4 GB is not fit to you, okay? So in this case, what will happen? The cloud service provider need to configure something which we call as customization. But many cloud service provider does not support such type of customization, right? Okay. Next is platform as a service and software as a service. You know that software as a service I told you in a very beginning diagram. Software as a service is close to user. Infrastructure as a service is nothing but your data center or the resources. So SaaS is often built on top of the platform as a service, right? Any software you are installing on top of a particular runtime environment. That's why it is saying SaaS is often built on top of the PaaS. Platform as a service, which in turn built on top of the infrastructure as a service. Like in our computer system, we have hardware. Okay, on top of hardware, we are installing the operating system. On top of the operating system, you are launching various application software. So the sequence is in the bottom to top. Okay, it is IS, PAS, SAS, or top to bottom you can say SAS, PAS, and IS, right? So platform case we are focusing on the operating system and the runtime library support. What kind of APIs are also there, that is also very much important for the platform. Here also, like I told you, there is a standardization of SMA is an important research problem. Here also, using standardized API and library is also an open resource problem, because all the cloud service providers are using their different APIs. Some cloud service provider is using open source API. Some cloud service provider has designed their own API to use the services. So again, there is a confusion when you want to migrate one cloud service provider to another cloud service provider in terms of your API and the library, right? So such things, if you standardize, then movement from one cloud service provider to another cloud service provider is easier, right? So in the platform, what we are doing, we are integrating computer system consisting of both hardware and software infrastructure. Because while you are configuring the platform, you are building on top of the infrastructure as a service. IS is going to provide you the infrastructure. Okay, so you are binding this hardware and software infrastructure into a single unit by the help of your platform as a service. One of the popular services that is your called as the Google App Engine. Google App Engine GAE is providing you platform as a service application. And it also provide this GAE is also provide automatic scaling load balancing. The scaling of the resources as well as balancing the load in each and every servers. Okay, is the responsibility of the platform as a service, which is provided by your Google App Engine. These are the 5 public cloud platform as a service provider. You can see their name in the first column. One is called as your Google App Engine. Second one is your Salesforce.com, Spruce.com, Microsoft Azure, and earlier it is called as Windows Azure, right? Next is Amazon Elastic, MapReduce. Next one is Anek. So Anek is generally a platform as a service, right? Platform as a service, but we are going for platform as a service, it requires infrastructure as a service as well. Okay. So you can see with respect to this cloud service provider, they are different in terms of your languages and developed tools. Somebody is using Java, somebody is using .NET framework, somebody using the C++ framework, right? In order to build this platform, right? The programming models, whatever they are using, also different. Somebody may use the MapReduce program, right? In which you know that MapReduce or Hadoop, there is a master node and there is a multiple worker node in order to get the job done. And their applications, these clouds application domain is also different. Their storage devices are also different, right? Somebody may be interested for customer relationship management, somebody may require for high performance computing applications, right? Somebody may go for e-commerce applications, whether it may be B2B, business to business, or it may be business to consumer as well, right? So in that way, these cloud offerings are different from each other, right? So you can explore these 5 cloud offerings, and you can also differentiate in terms of other characteristics and the features, right? But as you know that Amazon is a very popular platform, and Google App Engine also very popular in terms of mathematics. But Anek is providing various features. And Anek was developed by Professor Kumar and his group, right, at the University of Melbourne, Australia. So Anek is also used in many academic purposes. People are using this Anek platform, right? We also purchased this Anek platform, and due to this lockdown, they have not installed it, as per my knowledge, right? So soonly they will, if the institute will open, you have a demo on the Anek, so they will do some kind of programming to your Anek as well. Okay, next is you can see here the details about the App Engine, okay, how Google App Engine working. So you can see in the right part, users, right? User can access the cloud computing platform through web browser. In that web browser, how you are accessing by making an HTTP request. While you are typing a particular website, it is nothing but a HTTP or HTTPS request. Okay, hypertext transfer protocol or your secure HTTP, you are making the request, right? Ultimately, what you have to do, you have to make a request. Finally, you will get a response. Again, you will make a request, you will get a response, right? So it is taken care by the interface, that is nothing but a API, okay, or a user interface or maybe a web browser that is connected to the Google load balancer. Okay, so that load balancer will responsible for giving equal number of nodes to the underlying servers, right? There may be data server, there may be email server, okay, there may be any kind of servers to be managed by a load balancer because sometimes the load is low. So you have to see that the loads are equally distributed among the servers so that the server will not fail due to the overutilization, right? And what things you can do here? You can go for a application development because this is a runtime environment, right? So suppose I want to deploy a particular application. So this is the phase it is written here that is called the local development. So you can see you can build a particular applications. Suppose there is some bug is there in the applications, you can upgrade the applications, you can deploy the application in the environment, right? And you can test the application whether it is working or not. So this cycle is going on. Okay, this cycle is going on, and finally it will upload in the environment in order to deploy in a suitable server, right? So for this, we have a web application provider which is responsible for this local development and this managing this traffic control, version control, right? Traffic monitor version control. So it is controlling both the parts, right? While you have developed a particular applications, you can deploy in a underlying infrastructure. That's why for platform as a service, you require good infrastructure as a service. Without infrastructure, you cannot deploy the platform as a service, right? The next one is your software as a service. Software as a service is nothing but a browser initiated application software. So through a user interface or API on a browser, you are accessing the software. So if you look at the customer side, we are saying there is no upfront payment commitment, right? Or there is no need to pay for the services. Whatever services you will pay, you are going to pay for that only, right? You are not going to pay for anything extra. But you should not worry about that. That you will be overcharged, right? That's why there is no upfront investment in servers and software licensing. For example, I want to use a particular software that is used by a cloud service provider. Let X software I am using, right? Next server I am asking a particular cloud service provider, right? So once I get the X service for let's say 1 year, right? I need not worry about the licensing of that particular software, right? The licensing of the software should be taken care by the cloud service provider, right? For example, I am using this software. This software's validity is let's say will expire next 6 months, but I have asked for 1 year, right? I have asked for 1 year. So it is the responsibility of the cloud service provider to renew his license. So this software licensing is also not bothered by the user, right? Because it is the responsibility of the cloud service provider to provide such type of licensing. The very popular Google Gmail, Docs, and Microsoft SharePoint, you can say these are the live example of our software as a service. Many cloud service providers are providing joint services, as I told. Like Google is providing the joint service, Microsoft is also providing joint service. Apart from that, also many cloud service providers are there. They are providing the joint services, right? But in IS case, Amazon and Google is the famous one, especially Amazon gained so much revenue in the Panda infrastructure as a service. Okay, there are some success stories as well for the cloud computing, right? Which company is making more benefit or which company is benefited using cloud computing? There is some success stories are written in this particular slide. Apart from that, also there is so many things are there. Last one is called as to discover the new drugs, right, through DNA sequence analysis. Okay, some organizations require DNA sequence analysis. So analyzing this DNA sequence, you have, let's say, you have data sets, right, or any drug development, you need to analyze the DNA sequence, right. For that, you require a massive amount of computational power or massive storage also. So what they did, that company subscribed Amazon AWS. Okay, Amazon AWS provides such infrastructure so that they can develop, they can analyze the DNA sequence and can develop new drugs, right? So that is a true story behind the cloud computing environment. Second one is your New York Times, right? In India also we have a Times of India, Indian Times, right? Newspaper. Similarly, they have New York Times newspaper. New York Times decided to transfer from traditional way to the modern way. In traditional way, the newspaper is available hard copy only. But nowadays, if you see the newspaper is delivered as well as hard copy as well as in the soft copy. So what they decided, the New York Times decided, why not create a portal, right, in which all the traditional newspaper, traditional means hard copy newspaper, which is not there in the online, because earlier newspapers are not available online. Why not convert everything and everything should be available in a particular portal, right? So what they did, they have subscribed Amazon EC2 as well as 3, that is Amazon Simple Story Service, and they are able to convert all the newspaper within a limited time. Preferably, as I remember, it is 24 or 48 hours. Within 48 hours, all the traditional hard copy newspaper is converted to the software news in a soft copy, right? The soft copy is available in a particular portal. Okay. Similarly, you can see this Epiphany Boys. They are using the Microsoft Azure platform for doing the business to business transactions. You know that Walmart is there, right? Walmart is providing services to various marts like DMart, and these are purchasing from the Walmart. But a user cannot directly purchase from the Walmart, right? So that is a B2B transaction, business to business transactions, right? So that business to business transactions, if you see, that is also not small. So what they did, they have subscribed this Microsoft Azure platform, and Microsoft Azure is providing such a platform so that they are running their B2B, their businesses, and they are performing B2B transactions very easily. So these are various success stories with respect to uh, you can say with respect to the cloud computing applications, right? And you can go for also cloud mess up, right? Mess up, you know that you are merging one cloud with another cloud, or you are using multiple clouds simultaneously, right? In order to provide the services. Like I told you, one cloud service provider is not having sufficient resources or the resources whatever you require. That cloud service provider may request another cloud service provider who is having that services or who is fulfilling your request so that the same service can be provided to you, right? To the user, right? So that can be provided by the cloud master. Then we will discuss about the data center design and interconnection network. So you can see data center is having a large number of servers, okay, and these servers are connected to the interconnection network. Last class also I referred you about Taurus, TURUS Taurus, and there is your I told you about Hypercube, okay. So these are the interconnection network in which I can connect the server, right? Various interconnection networks are there, right? If you study parallel distributed computing, you will get details about the interconnection network. Another type of data center you can create using the truck. Like you know that whenever you are traveling in the national highway, you have seen there is a very big truck, right? Very big truck. The truck is containing many cars or many trucks at the same. 20, 30 cars can be okay. Their parts can be transferred from one place to another by the help of a heavy truck. Similarly, the data center can also be possible through this truck container. In general, it is called a 40 feet top container server. This container contains several servers, right? So that at any point, any place, if you require the resources, that can be provided. That's why Gartner is a research advisory firm. The vice president of Gartner suggested that by 2023, the services of the cloud will be provided just like a distributed technique. Okay. Suppose you require resources at this point, and you think that there is a scarcity of resources, immediately the resources will be available. Right? So that is possible by the help of this cloud container. Okay. And if you view a data center, the data center is nothing but 11 times the size of a football field under one roof. It is 11 times the size of a football court. You can imagine what is the size. And it varies with respect to the number of servers. One study says it is 4 lakh to 1 million servers, but it varies with respect to the data center. One data center may have also 50,000 to 80,000 servers as well. Many analyses suggested how many servers are there in the data center, but this pictures vary with respect to the reports. Yes, it is written also that in small data center, you may have only 1,000 servers as well. If it is a big data center, you have in the million number of servers, but if it is a small data center, you may have 1,000 servers, right? And if you see the cost of the operating a particular data center, the network cost is $13 per Mbps, storage cost is $0.4 per GB, and apart from that, you have cooling cost and your monitoring cost, and you have also administrative staff cost in order to monitor the resources of a particular data center. So this is a typical example, you can say. This is an example of a data center. Here there is a huge data center you can see, which is 11 times the size of a football field, which is having 4 lakh to 1 million servers, right? See, this is a practical example and a practical picture of a particular data center. Imagine if this data center is having this much servers, like 4 lakhs to 1 million servers. How much power is required? How much cooling is required? What is the environmental impact? That's why developing an energy efficient algorithm to manage these resources is very much important. And you know that I told you in some class, 4 million data centers are there in US only. So imagine all over the world. How much energy is required? Okay? Or how much cooling is required? So that you imagine how you can develop the energy efficient algorithm for cloud computing. Okay, in data center, there is another data center is stated as that there is a 2,000 servers are there. In each server, you have a 8 GB of dynamic RAM and 1 TB of disk drives. Right, it varies. These configurations are varies with respect to the server. I will not say that this is the strict one. This is the strict data, but this is flexible. Okay, and each group is having 40 servers. Right, 40 servers are present in a particular group, and they are connected through 1 Gbps link to a rack level switch, right? Because the load will come to a load balancer, the load balancer is going to propagate that load to various switches. Finally, the switch will give the load to the server. So these 1 Gbps ports are connecting the rack level to the cluster level. First is your the servers are connected to the switch, that is called as a rack level switch. Then rack level switch is connected to the cluster level switch using a 1 Gbps port, right? And every time in a data center, the main part is there may be a CPU failure, there may be a disk failure, there may be a network failure. Even if there is a failure occur, you have to make sure that your services should be provided on interrupted. Right? That is the main goal of doing a particular data center. And you have to ensure that reliability is there. Reliability can be achieved through a RAID technology, redundant array independent disk. RAID. You can explore RAID. There are various levels are there, right? RAID has several levels. With respect to several levels, the redundancy level is specified. So if you duplicate the things, duplicate the hardware, then the reliability will increase, right? Because if a particular hardware is failed, then the backup hardware will come into picture. Okay, but going for redundancy is also costly. So you have to compensate this here. Similarly, in the software case, multiple copies of data in different locations. Okay. The data is multiple copies of a data is present in various locations. In the data center, you have multiple copies. If one software is failed, then another copy can be provided. And in data center also has a raised floor. Raised floor means like we are doing ceiling. Similarly, there is a flooring. Why we are doing this raised floor? Because we want to hide the cables and power lines and cooling supplies. Right? You can see this diagram so that the idea is more clear. So this one, what we are doing here, we are making it for the cooling purpose. Okay, or in wire if you want to put here, so you need to hide the complexity. Okay, that you can do. That's why the cooling system in a raised floor data center. Okay, the cooling system is present here. Similarly, you can say underfloor area, right? That is used for the cooling the server racks. So here you can suppose air condition is there or some cooling unit is there, where you can say you can send you can make this system cool, right? For that you can use this particular space, right? And apart from that, also you have a CRAC system, which is your computer room air conditioning system. CRAC unit is present here. This CRAC unit is not providing cold air in this space, it is also providing cold air in this space, and it is also collecting the hot air. Whatever generated from these resources, it is transferred to the CRAC unit, and cold air is also providing to these floors. By the help of these floors, the cold air is provided, right? So you can say that the servers are available in the here in the racks, right? Which is getting the your cold air and generating the hot air that is collected by the CRAC unit. Okay, that is provided, right? That is given to outside the data center, right? So the incoming cool temperature, if you see in the case of data center, it is generally 12 to 14 degrees Celsius, and we are using the chiller. We are using chiller here, right? The CRAC unit is having the chiller, right? So that this hot air can be removed outside, right? Similarly, the data center has several requirements. There are 5 special requirements are there. The first one is low latency and high bandwidth. Already we discussed. The data should be as minimum as possible, and bandwidth should be as maximum as possible. The cost of the services should be as low as possible. And in order to make parallelism, we require API communication support, or we can use Mininet. And also, fault tolerance is provided by the data center. If there is a hardware failure or software failure or disk failure, that can be done. Okay, that can be replaced by the appropriate one, so that the services will be provided using this fault tolerance technology. The second one is so these are the 5 requirements. One is your low latency, high bandwidth, low cost, API communication support, and fault tolerance. These are the 5 requirements of a particular data center. Apart from that, we have high bisection bandwidth. You have to see that how you can decompose a particular network into 2 parts. If a network is given to you, how you can cut a network into 2 different parts, and what is the minimum number of lines you are disconnecting in order to making a single network into 2 different networks. That's why we say minimum number of links, but to divide the network into 2 halves, that is called the bisectional bandwidth. But if you sum their bandwidth, each and every link is a bandwidth. Why the link is used? Link is used to transfer the data. So each and every link has a bandwidth. If you sum such bandwidth, that we call as a this bandwidth should be high. That's why it is called as a high bisection bandwidth. So if a network is there, how you can decompose the network? How many minimum lines you have to decompose? You have to sum their bandwidth in order to calculate the bisection bandwidth. Here also you can see that you can access the resources distributively, and it is providing one-to-many communication, like broadcasting. In broadcasting case, like radio case also, radio is telecasted in a particular place, but there is many people can listen the radio, right? So that is a one-to-many communication. So distributed file access is providing such communications, and sometimes you require the network with topology to restructure, right? Based upon the requirement, based upon the configuration of a particular data center, it may happen that whatever topology you are following, by adding new resources, you are going to reconfigure the topology or restructure the topology, right? So that is the data center interconnection networks. And data center owners buy the server containers. Nowadays, they are purchasing the container. The advantages is that this container can be placed in a truck so that it can be moved from one position to another position. If it is moved from one position to another position, what is the advantages you are going to get? You are getting the resources of a, you are getting one new technology that is called as moving cloud. It is moving from one unit to another unit, right? That's a moving cloud you are getting, and as per your requirement, you can place the container. That is the advantages you are getting in comparison to a traditional data center where it is kept in a single place. So one can also connect multiple containers. Like I keep 5-6 trucks at the same time. The truck is fully loaded with your server, so I can connect these trucks, right? Like I told you that the football size, it is 11 times. If you imagine 11 times of a football size, say, football size, court size is same as your data center. So similarly, I can place multiple blocks in a single place in order to provide the resources. So the resources, if you see, while the resources is provided to a particular connections, you have to ensure that multiple paths are there. Why multiple paths is required? It may happen that one path is overloaded, okay, or one path is having collision, one path is used by multiple people. So there should be an alternate path also there to use that resources. That's why in between two servers, it is required to having multiple paths, so that if there is a failure in a one path, you can move to another path very easily. So you can see in this network, you have the computers, you have various switches, and here also you have switches. These switches are called as your core switch, and this switch is called as your base switch. The switch and your computers together called as a pod. So this is one pod, this is another pod 1, this is pod 2 and pod 3. Okay. So the request is coming to the core switch, and core switch is giving the request to the base switch, and finally it is given as a computer resources. Right? So in this way you can make a connection. This connection require your interconnection network. So whatever interconnection network you are seeing in this particular slide, that is called as a FAT tree. FAT tree is an interconnection network in which we have connected the core switch with a particular pod. Right? So if you see, each and every computer resources are connected, okay, through the switch, and you can see multiple paths exist between the resources, right? You can see that these particular resources can be reached using two different ports. So if there is a link is down or there is any failure, I can use the alternate resources as well, right? You can see this whatever the switches, one switches we are using to connect the server, another switch you are using to modify the operating system running on the server. So there may be a switch centric or there may be a server centric. So in the switch centric case, your switches are used to connect the server. Like here, whatever you can see that resources are connected to the switch. In server centric, what we are doing, we are modifying the operating system running on the server. Okay. So this particular structure in the bottom layer, you can see the resources are able. In the top layer, you have your core switch, and this core switch and bottom layer is connected through your edge switches, right? And a group of aggregation of the switches and edge switches and their leaf nodes are called as a pod. I already mentioned you, right? Core switches provide the path among different ports. Core switches is providing different paths to the port, right? Multiple paths are provided due to due to achieving the fault tolerance perspective. And there may be a routing table you can maintain, like you have studied AODB protocol, DSR protocol. Similarly, here you can use multiple routing protocols, right? And routing tables are maintained so that you will know that who is the neighbor node and how many hops are required to reach the resources, right? So this is all about your data center design and interconnection network. So So we'll stop here.